In the last video, we went through the steps to solve these inequalities. And actually, I gave you the steps. I probably should have had a first step, which I think about, which applies now. I should have said the first step is really you need to set one side of your inequality equal to 0. Now this one, the problem we did the last video, it already had a 0 here, so I didn't really think about it. But now look at this problem. It asks me to solve 6x cubed greater than 24x squared. In order to solve this, the first thing I have to do is to get one side equal to 0. So I'm going to subtract 24x squared from both sides. So 6x cubed minus 24x squared is greater than 0. So I know, ultimately, I'm looking for all the values of x that will cause this expression to be a positive, right? My solution is, when is this going to be greater than 0? When is it going to be positive? So now I'm going to go through these steps again. I'm going to factor, find the zeros, create my graph with my regions, and then use the sign chart to figure out if the regions are positive or negative. And at that point, I've pretty much solved the problem. So factoring two terms, binomial, and I do have a GCF. I have a 6 in common and also an x squared. So what I have left, x minus 4. Once again, in the last video I said, if you can't factor, then you're probably not going to be able to solve these inequalities. At least not the method we're doing now. But since we're able to factor it now, we need to find the zeros of the expression. So the zeros are the values of x that would cause the whole expression equal 0. So I look at my x's, I got an x squared here. Obviously, if x is 0, x squared would be 0, and that would cause the whole left-hand side to be 0. And now I look at my parentheses, and if x is 4, then once again the whole left-hand side would be 0. So those are my zeros. I use those zeros to now break my graph up into regions. So here's region 1, region 2, region 3. Once again, you can think of negative infinity is there and infinity is here. So now, based upon these regions, I'm going to do my sign chart. 3 regions. TP stands for the test point, so that's where I choose a value of x in each of the regions. So region 1, I'll choose -1. Region 2, I'll choose 1. Region 3, I'll choose 5. And now I have to list my factors from this factored equation, 6x squared and x minus 4, then overall. So now I go to each region and plug in my test point, and I start looking at the signs, whether they're positive or negative. So -1 into here, -1 squared is +1, so that's a positive number. -1 here, it's negative. Positive times a negative is a negative. I've just determined region 1's a negative region. Region 2, with my test point is 1, I plug in 1 into here. It's just 6, so it's positive. Plug in 1 into here and it's negative. Positive times a negative, looks like region 2 is negative. It's interesting, two negative regions right next to each other. Now region 3, I plug in 5 into here, that's positive. 5 into here is positive, two positives. Then region 3 is positive. But like I've said a few times now, once you figure out the signs of your region, you've basically solved the problem. Because I go up here and I say, what are they asking me? They're asking me when is this expression, for what values of x is this expression greater than 0, which means where is it positive? So I'm looking for the positive region. There's actually only one positive region. So in this case, the solution would be 4 to infinity. All right. So now, let's go to another type of inequality. Except instead of this, we call these like polynomials, these first two examples. Now we're going to start looking at solving inequalities with rational expressions. Now the good thing is, the way we're going to solve these kinds of problems is very similar to what we've just done, with maybe one other thing we have to account for. So for instance, I want to solve this linear inequality. I want to know the values of x that are going to make this true. X plus 1 over x minus 2. What values of x would cause that to be greater than or equal to 0? Basically, once again, where to be positive or 0. Now the nice thing is the steps you go through to solve this one are very similar, almost identical to the steps we just talked about. The only change is, first of all, you factor nothing to factor top and bottom. Then you find the zeros. Now zeros we talk about zeros. Zeros actually only come from the numerator, because zeros are the values of x that make the expression equal to 0. You can't go into the denominator. You can never have this denominator equals 0. So there's no zeros from the denominator. What I'm going to call them, I'm just going to make this up. Let's call them domain points. Why did I call them that? Remember when we talked about finding the domain of expressions? I said the thing you do is you go to the denominator and you decide what are the values of x that would cause the denominator to be 0. Because when you do that, you know that those are the points, or that's the values that x could never be. We do that. So here's what we do. We look at the zeros. The zeros, you look at the numerator and say what values of x would cause the numerator to be 0. In this case. But these domain points say you also have to go look at the bottom and ask what values of x would cause the bottom to be 0. Now really, what I'm going to do now is I'm going to create a graph and a sign chart, and I'm going to use both of these values of x as sort of my boundary, my border points. So in other words, now what I normally do is whatever border or boundary points I get from the denominator, I just like to put a box around it, because when I finish the problem at the very end, it's going to be important sometimes to know where this 2 came from. Did this 2 come from the numerator or the denominator? This box says it came from the denominator. If I go ahead now, break it up into 3 regions, and now I do a sign chart. Three regions. Test point, region 1, I'll say -2, region 2, say 0, region 3, I'll say 3. And now when I list my factors, I list both from the top and the bottom. So x plus 1 comes from the top, x minus 2 comes from the bottom. I've got my overall. So now we're going to figure out what the signs of each of these 3 regions are. Region 1, when the test point's -2, -2 plus 1 is negative. -2 minus 2 is negative. 2 negatives multiplied together is positive. I know region 1 is a positive region, meaning any value of x I choose between -infinity and -1. If I plug that into this, it's going to give me a positive number. Region 2, plug in 0 here, it's positive, 0 here, it's negative, positive times a negative. Region 2 is a negative region. Region 3, plug in 3, it's positive, 3, it's positive. Region 3, it's positive. So now, like always, once you know the signs of your region, you're pretty much done. I'm looking for where this is greater than or equal to 0. So where is it positive? Looks like region 1 and region 3. So the solution starts at -infinity and it goes to 1. Let's be careful. Should I include -1 or not? Well, -1 is a real 0. And since I'm including the expression equals 0, I'm going to include the -1. Because when x is -1, that causes the whole expression to be 0. And that's what I want. Now I'm going to union it with this third region. So I look at this boundary point. Now normally you might think you would include the 2 because it's greater or equal to, but actually you do not, because that 2 came from the denominator. So basically this expression, x can never equal 2. So if I want to give the interval for region 3, I do not include 2, and I just go on to infinity. So here's a case where it becomes important where these boundary points come from. If it's from the numerator, for this problem you can include it, but if it's from the boundary points from the denominator, you cannot include it. Just for fun, say if greater than equal to, they just said greater than. How would the solution change? Well, you still do the positive region. Except in this case, you would not include the -1, because the -1 is where it's 0, and I'm not including the 0, and then union it with so really only one change, this bracket and this parenthesis. All right, let's do one more of those kinds of problems. This one's got a little bit of a twist to it. We're asked to solve this inequality. Now it looks sort of kind of like the problem we just did, but there's actually one big difference. The previous problem, we had our rational expression greater or equal to 0, but we don't have a 0 here, we have a 1. And if you remember the step I added, first thing you have to do to solve these, you got to get one side equal to 0. So I'm going to have to subtract 1 from both sides. This is going to look sort of funky. X plus 1 over x minus 2 minus 1 less than or equal to 0. But as it stands right now, there's no way I can solve this thing. What I need to do is trying to combine these two terms into one fraction. So I need a common denominator. So let's change 1 to x minus 2 over x minus 2, right? So this fraction here is 1. But now, since I have a common denominator, I can now combine them. X plus 1 minus x minus 2. And now be careful with my minus signs. This numerator, x plus 1 minus x minus a negative 2. Now if I simplify this, actually x minus x, let's cancel out. 1 plus 2. So it actually simplifies, reduces down to 3 over x minus 2. At this point, I can sort of start the process. One side 0. There are no zeros of x, but there are some what I call domain points. In other words, x can never be 2 in the denominator. That's a domain point. And the domain point is how I break up. There's only going to be 2 regions here. I still do a sign chart. Test point 0 and 3. I've only got one factor here, the x minus 2. And then overall. When x is 0, this is negative. Means overall is negative. When x is 3, it's positive. Overall is positive. So basically, region 1 is negative, region 2 is positive. The problem says, where is this expression less than or equal to 0? Where is it negative? That's what I'm really looking for. Right here. So the solution would be negative infinity. Now notice 2, I go to 2. But I still cannot include 2 because 2 comes from the denominator. So this should be the solution. All right, so hopefully now, when you go in and do your homework and take the quiz, when you have some of these inequalities to solve, you'll be able to work through them. Once again, what I've taught you is probably not in the book, but to me, it seems pretty simple and it makes sense, and hopefully it might help some of you.